Beneath the snow-draped peaks of California's Sierra Nevada lies a threat powerful enough to change the world. Tourists come to Mammoth Lakes for its ski slopes and hot springs, never realizing they stand atop one of Earth's largest active supervolcanoes, a geological time bomb known as the Long Valley Caldera. When it last erupted, it unleashed more than 600 cubic kilometers of magma, blanketing half of North America in ash and plunging the planet into a volcanic winter. The scar of that cataclysm still stretches 20 miles across the landscape, quiet now, but far from dead. Scientists monitoring the caldera have detected the ground slowly rising, gases seeping through the soil, and swarms of tiny earthquakes whispering from the depths. What they've discovered is chilling. The magma chamber beneath Long Valley remains partially molten, and it lies in one of the most earthquake-prone regions in the world. A future tremor, even hundreds of miles away, could awaken it. While the world watches Yellowstone, California's own sleeping giant is stirring. Today, let's delve into the dangers of the Long Valley Caldera and the potential for a future mega eruption. Don't forget to click on that subscribe button and like this video, as it's the best way to support this channel. The Long Valley Caldera was born in a moment of unimaginable violence. Around 760,000 years ago, a colossal eruption tore through the crust of eastern California, releasing nearly 600 cubic kilometers of magma, enough to fill Lake Tahoe 100 times. As the magma chamber emptied, the surface collapsed, leaving behind a vast oval depression roughly 32 kilometers long and 17 kilometers wide. The eruption's fallout, known as the Bishop Tuff, blanketed the western United States in glowing ash that fused into the Golden Cliffs, still visible east of the Sierra Nevada. The scars of that eruption remain etched into the land. Beneath the town of Mammoth Lakes and its surrounding alpine basins, the caldera floor still rises and sinks as magma stirs far below. Modern imaging reveals that the reservoir remains 20 to 30% molten, forming not one massive magma pool, but a branching network of molten and solid rock, an underground organism that breathes, cools, and occasionally awakens. Long Valley's instability is intensified by its precarious position between two tectonic giants: the Sierra Nevada block to the west, sliding northwest, and the Basin and Range Province to the east, where the crust is stretching apart. Each movement opens pathways for magma to migrate upward, feeding hot springs, fumaroles, and subtle ground deformation. It is connected to nearby volcanic centers like Mammoth Mountain and the Mono Inyo craters, which last erupted just 600 years ago. These systems share the same deep magmatic source, meaning unrest in one can influence the others. The surrounding fault zones, the Owens Valley, White Mountains, and Eastern California Shear Zone, further tie Long Valley into California's seismic web. When a powerful earthquake strikes nearby, it can shift stress along these fractures, squeezing or releasing pressure in the magma chamber. In 1980, this process caused the caldera to rise 25 centimeters in weeks, proving that Long Valley is not dormant, but part of a vast, restless system where one fault's movement can awaken another. The eruption that created the Long Valley Caldera ranks among the largest in Earth's history, rivaling Yellowstone's most powerful blasts. Ash from the Bishop Tuff has been discovered as far away as Kansas and Nebraska, a lasting imprint of an event that reshaped North America. Yet the eruption did not end the volcano's story. Its energy endures beneath the Sierra Nevada. In the millennia that followed, Long Valley continued to stir. Smaller rhyolite domes formed along its edges, and the Mono Inyo craters to the north erupted as recently as 600 years ago. Events remembered in Native American stories of darkened skies and falling ash. Modern unrest began in May 1980, when 4 earthquakes over magnitude 6 struck just south of the caldera. Within weeks, the ground lifted, gas vents opened, and thousands of smaller quakes rattled Mammoth Lakes. Through the 1980s and 1990s, waves of uplift and seismic swarms continued, and deadly carbon dioxide emissions near Horseshoe Lake proved the volcano was still breathing. The activity has never truly ceased. Even in the 2010s, new earthquake swarms and gas fluctuations signaled a restless system, a reminder that Long Valley is not extinct, only sleeping. In recent years, Long Valley's pulse has continued. In 2024, the U.S. Geological Survey recorded several small earthquake swarms within the caldera, most between magnitude 1.0 and 2.2, clustering near Mammoth Mountain and the southern rim. Though minor, these quakes revealed that magma and hot fluids still move beneath the crust. Satellites detected slight ground inflation, only millimeters to centimeters, caused by pressure shifts deep below, while sensors near Horseshoe Lake measured fluctuating carbon dioxide emissions, continuing to kill trees in patches of forest. Scientists stress that such unrest doesn't mean an eruption is imminent. It reflects the volcano's natural breathing cycle. Yet every tremor is carefully studied because of Long Valley's volatile history. In 2025, the pattern persisted. Small but steady quakes rippled through the caldera and along nearby faults, confirming that the system remains restless. Caltech studies found that the magma chamber, though cooling, is still mush-like and mobile, capable of generating heat, gas, and subtle ground motion. It's a reminder that even a quiet supervolcano can still move enough to reshape the land above it. Despite the calm surface, Long Valley remains classified as a very high-threat volcano, watched closely because history has shown how quickly its silence can break. If the Long Valley Caldera were to erupt again, the outcome would depend on how much magma reached the surface. In the most extreme scenario, another super eruption like the one 760,000 years ago, the devastation would be unimaginable. Ash columns could soar 30 kilometers into the stratosphere, spreading volcanic dust across North America. Towns within 100 kilometers would vanish beneath pyroclastic flows, and the Sierra Nevada would be buried under a suffocating gray haze. Ash could reach the Great Plains, grounding flights, poisoning water, and dimming sunlight worldwide. In such an event, millions of lives across the western United States would be at risk, not only from the eruption, but from famine and the volcanic winter that would follow. Scientists stress that such a catastrophe is extremely unlikely, yet smaller eruptions could still cause havoc. A moderate series of blasts could bury mammoth lakes under ash, trigger mass evacuations, and paralyze air travel across the West. But the greater danger lies in a triggered awakening. Long Valley sits within one of North America's most unstable fault networks. A large earthquake along the Owens Valley, White Mountains, or Walker Lane, faults could jolt its magma chamber, just as the 1980 magnitude 6 sequence did, causing uplift and swarms of quakes. A future magnitude 7 event could easily disturb the delicate pressure balance, open new fractures, and set magma or gas in motion. Even without a full eruption, the effects could devastate California. Predicting when Long Valley might awaken is impossible, but scientists warn that its calm is deceptive, the silence of a giant that once destroyed a continent and could one day do it again. No volcanic system in California is watched more closely than Long Valley. The U.S. Geological Survey and the California Volcano Observatory operate an extensive network of seismometers, GPS stations, and gas sensors across the caldera, while satellites track even the smallest ground movements, creating a real-time picture of the volcano's inner workings. One of its greatest hazards is carbon dioxide near Horseshoe Lake. Invisible gas seeps from the ground, killing trees and posing a silent danger to hikers. Scientists study these emissions carefully, as changes can signal shifting magma or rising pressure deep below. Monitoring also extends to nearby fault zones like the Owens Valley and Walker Lane, where earthquakes can influence the caldera's behavior. Every tremor is analyzed for how it might disturb the magma chamber. Preparedness is equally critical. If unrest escalates, Mammoth Lake's residents would receive immediate evacuation alerts, and air traffic across the western U.S. could be diverted. Local authorities regularly rehearse response plans with scientists, knowing that conditions here can change quickly. The Long Valley Caldera sleeps, but its heart still beats. Beneath the Sierra Nevada, magma stirs and gases rise through fractures, quiet reminders of the eruption that once reshaped a continent. Scientists don't expect another super eruption anytime soon, perhaps not for hundreds of millennia. Yet the volcano's restless nature demands respect. In a land where mountains shift and faults grind daily, no volcano is ever truly silent. Each quake that ripples through eastern California sends a pulse through Long Valley's buried magma chamber, proof that the forces shaping this landscape remain alive. For now, Mammoth Lakes lies calm, its hot springs and forests masking the power below. But scientists continue to measure, listen, and wait, knowing that stillness here is temporary. One day, the silence may break again, reminding the world just how fragile the line is between beauty and the Earth's untamed power.